All right, another way to describe the relationship between two variables using our same scenario here of tip amount and total cost of the meal is a graphical description. So fill these in with me here, but it's simply a plot of the data points on an appropriately labeled and scaled rectangular coordinate system. So the idea here is to plot these points, which really represents this information as well, on a rectangular coordinate system. Now, to make a rectangular coordinate system, you need two axes. You need a horizontal axis and you need a vertical axis, and always the horizontal axis will reference the input variable or values of the input variable, meaning these guys, the total cost of your meal, and the vertical axis will always represent output values or values of the output variable. So that's these guys. So if you notice I drew these in, you should too. So this often is called the input axis. This is often called the output axis. So our input variable is the total cost of the meal. I'm going to write that here. Which we could also just simply say, hey, that was C for us. Here this references tip amount, so I'm going to write that here, which was the letter T for us. Alright, so there they are labeled, the axes labeled, and we will ask you to do this on an exam like this. And the next piece is scaling our axes. So you got to take a look at your input values, what they range from, look at the grid, see what you have, and the goal is to use as much of this grid as possible. So if you, after some thought, you should come up with each grid line represent $2 here along this horizontal axis. So 2, 4, 6, 8, 10, and 2, 4, 6, 8, 10. So that's 20 marker. 2, 4, 6, 8, 10. So that's my 30 marker. And the output values or the tip amount range from 170 to 641. So depending on how much room you have, but we can get away with each grid line representing $1. Alright, so there they are. Alright, so I'm going to graph these points here. Now if you remember, graphing an ordered pair like this, we start at the origin and we go along 850 along the input axis, positive, so to the right, and then up along the output axis 1.70. That's up because that's positive. So I don't know if I said that right, but that's right from the origin, that's up from the horizontal axis. So 850, so there's 2, 4, 6, 8, there's 9, so, and then what are we going to do? Up $1.70. So there's, you see my little points in there. But $12 and $2.40. So starting from here, we're going to go to 12 and then 2.40. So that's 1, 2.40s right there. 16.90 is associated with $3.38. So along here, 2, 4, 6, 16.90. So that's about right there. And 3.38. So there's 3.50. So somewhere right in there. What we're after, and make sure I got that right. That's 12, 14, 16. Okay, so let's do 32.05. So we don't have enough grid line, but that's okay. There's 32.05ish, $6.41. So that would be right here. 650 is here, so maybe just below that. So what we say here is this set of points completely describes the relationship between these two variables. And so we need this information on there. Now, we didn't talk about this, but I guess we can go back and do it now. Would it make sense to have a zero input value? Meaning total cost is zero. Meaning you go to a Mexican food joint and you have the chips and salsa special and you don't pay for anything. You eat that chips and salsa and you walk. I guess that's one way to do it. You may think, well, no, that's not right. You go and buy something, so maybe that doesn't make sense. But if you did, I mean, you wouldn't pay any tip amount. But what about a negative value? Would a negative value make sense, like a negative $5, meaning some students may say, well, somebody could pay you to go out to eat. Well, let's not consider that. I mean, would it make sense on a normal day you'd go out and have an input value here, a total cost of a meal of -5? So no. So just be aware that we are going to ask you to think about input values that make sense in a contextual situation.